Hey guys, hold on just a second. I'll be there. I'm having technical
Holy
difficulties.
cow.
Yeah. Hey, now we're back up and working again. All right.
Clifton, what are you doing, man?
Well, man, I was having some problems with my computer, and I thought, well, Howard's got me on this project where I got to write up another newsletter for the conference, and man, I'm having some computer problems. So I thought I'd just get the typewriter out, and because I can still use a typewriter. I mean, this is the mechanical version of what we do on a computer, isn't it? Right?
Wow, yeah, that's pretty cool. I haven't seen one of those in years.
I know, but it still does the same thing. Hello, Mr. Tebby. Well, let's talk about things for a little bit, because this really is kind of segues into what we're talking about here for the show today, right? So we're going through a evolution in our industry, and we have a lot of things to talk about when it comes to proper tools and understanding the changes that are around us, because we have a lot of people that are very hesitant to change and evolve, especially when it comes to tools and technologies. And definitely, everyone, tell us where you're joining us from today. We'd love to know how big, how broad this HVAC community is growing into. So let's talk about something here just for a second, right? When we are hesitant to bring new tools and new technologies into the classroom, we really are not doing a justice to our youth who have grown up with technology in their hands, right? Hey, Bill Spone, how are you? Well, let's really get into tools in depth and where we came from to see where we're going. And I got a few things I want to cover too. Everyone that is joining us, we really want to see you at AHR next week. I'm going to be there. Ty's going to be there. Eric's going to be there. We got Daniel. We got most of the team is going to be hanging out at the AHR Expo. And then after that, we're going to be at the National HVACR Education Conference in March. Oh, we'll be at the symposium in February. But we needed to bring to you some very special opportunities at the conference this year. So Fluke has actually stepped in to help us get you to the conference if you're struggling, because we know as educators, sometimes it's not always in the budget. So Fluke is doing a sponsorship right now. So Fluke is going to be sponsoring free admission to the National HVACR Education Conference for free registration. So how do you get that? Well, it's actually really, really easy. Fluke wants to see you in use with one of their tools. So we would like for you to come up with a 30-second video of you using a Fluke tool. I know I've got mine right here. I've got my 373 hanging on the wall. Ty, could you give us a demo of what we would like to see on a 30-second video?
Yeah, put me on the spot. Yeah, no, I'm going to check amps. I'm going to flip it over here to some amps. I'm going to clip it around a wire and see how fast those electrons are moving back and forth.
Excellent. So really, we just want to see you in action, right? Just show us you using a Fluke tool and use that QR to send it over to us, or I'll put the link in here as well. And we want to be able to use those for some promotions. So there's even a button to toggle to say that we can use it for promotion. And then you can be registered for there's 2 free admissions registrations into the National HVACR Education Conference. And we've even had an update to the conference. We've been showing that it was the 25th to the 27th, and that is the class register, but we have another very special thing going on this year. So Daikin is a primary sponsor for our conference, and they're going to be throwing a celebration for their 100th year anniversary on Sunday from 5 to 7. There are some very, very cool things happening, very special time to be hanging out with us on Sunday. So if you're planning on getting in on Sunday, make sure you get there in time to join us for the Daikin 100-year celebration that's taking place. So all of that being said, let's digress a little bit. And let's dive into some of the evolution of tools and equipment. What do you think? That sounds good to me. Oh,
Diving in. I'm diving in.
Our Eric Kaiser from True Tech Tools, another sponsor of the National HVACR Education Conference, as well as the top 25 educators. We'll be seeing some very cool things from True Tech at the conference as well. So
Happy to do that. That was a really fun thing to do.
Oh man, I'm telling you. Did you know we had over 1,000 of those applicants for that?
Really?
So
Wow,
there's a lot, yeah.
1,000 people listed on
It
that.
was
Wow.
a lot of sorting through for those top 25, and so it came down to the top 25 amounts of nominations for those top 25 spots.
Yeah, it was
So
all based on votes, and it was there was no list put out there from what I understand, right? It was just random people writing a name down,
that was it. And that's where we ended up.
and then you got to sort through everybody spelling, misspelling different names, right?
Yeah. So
I want to know how many people spelled Ty's last name as Banana Man.
oh my gosh. Did I just hear that? All right, I'll come
That's
back
my
to that one
nickname. TY Banana Man.
All right, so Eric Kaiser, let's talk a little bit about tools because we are starting to see an evolution of tools. We've seen that for a decade or so. And let's talk about ways that we can utilize tools for very critical measurements, very specific measurements as we start talking about critical charges and systems and proper performance for installations and servicing.
I love that. And let's talk about, I mean, let's just talk about evolution in general, right? Evolution's been happening for, well, longer than we can remember. I mean, humans, we've been evolving. The world around us has been evolving for eons now. You know, it's a long time. So we continue to evolve. And the thing about evolution, especially technology-wise, is it has been, I'll say, speeding up
Yes.
in our lifetimes.
Yeah.
It's been increasing. I think back, you know, to the first iPhone, the first smartphones out there, the touchscreen smartphones, and that wasn't that long ago. Like that was less than 20 years ago. You know, and if evolution didn't happen, you know, we might still be living in places like this rather than in places like this today.
So very true.
You know, this is a evolutionary curve, right? We go from one place to another, and it happens all the time. So it happens a lot in our trade, which this is front and center for all of us is what has evolved in our trade. And there is no way in this short show that we're going to cover everything.
No, absolutely not.
But I want to highlight a couple things. And
Okay.
I want to bring a couple things forward, and I want us to think about some things. And I've got some, you know, I got some things down here, some old things. You know, I got some old things, and you know, maybe we got some new things and some things in between. So we'll talk a little bit about that, about what's happened. But let's step into just talking in general here about evolution. And this is something that has been happening. I mean, it's happened in my time in the trade.
Yeah.
You know, I'm right close to 20 years now. And you know, when I came into the trade, we were at the HCFCs and we were transitioning into the HFCs, and now we've gone next step to HFOs. You know, I don't know. You guys probably worked with some of the CFCs because I think both of you have been in this trade a little longer than I have.
I see Ty has some there. I have a challenge for our participants today. All right.
Oh, wow.
Look at that. That's a good one there.
That is a good one.
So in this challenge, I want us to think about this for a little bit. All right. And we can put it into the chat when you come up with an answer. This will give you something to do while we're talking about these things. I'd like to use this for demonstration. So I actually grew up with the dial-a-charge. It wasn't what I used in the field, but I was taught on it so that I could understand what I was actually doing. Look, Ty's got his right there. All right, here's maybe a challenge number 2. I have in my dial-a-charge liquid and vapor. And I don't have my thermometer. I just kicked off my heat pump. I would say it's probably 70-ish degrees in here. And I have a stable pressure of... let's go for about 75 PSI. Let's go see if you can figure out what refrigerant is in my dial-a-charge. Ty, what kind of a temperature and pressure correlation have you got?
Let's 79 degrees for me, and I'm at a pressure of right about 75 PSI gauge.
Okay. All right. Ooh, Wow. All right. So a little bit of pulling your PT charts out while we're going through our lessons and talk about these different refrigerants. See if you can tell us which refrigerants are we using in these style of charge CFCs, HCFCs, HFCs, or HFO. Sorry about that, Eric.
No. I love it. I love it. Because where are you going to go get a PT chart at today, right?
That's right. Are we going to
Where's
use?
mine?
Oh, has there been an evolution of PT charts
Oh my
as
gosh.
well?
This is the best PT chart ever.
Okay, so am I right or wrong for using my slide PT chart versus my handheld chart?
You might be either one.
Yeah.
I mean,
as
if
long as
it
I'm
gets
using
you,
it.
if it gets you to the end point,
Mhm.
it's probably right. But it depends on what your goal is. Is your goal to do things the same way you've always done them, or is your goal to maybe do things a little bit faster and a little bit more accurately
Yeah, exactly.
as we evolve?
Okay.
Right? If we learn something one time and we just do it that same way for the next 10, 20, 30, 40 years, right? We've stopped evolution at that point. Right?
Yeah.
I mean, smartphones have evolved in the past 20 years dramatically. You know, we were right before the first iPhone came out, we had Blackberries. You know, if anybody remembers those.
Yeah, absolutely, I do.
You know, some people have probably never even seen one, maybe in a museum. 'Cause they were great while they were out, but then they just disappeared,
Yeah.
right?
And
Something
you,
better came along, and the society jumped on something better. So
you can't
you
forget
know,
the pocket full of quarters for the payphone.
Mhm.
who carries that around?
Yeah.
Oh, Nextel. There's somebody put Nextel in there. Boy, what happened to Nextel? Let me think. What happened to Nextel? Evolution.
Evolution has happened.
Evolution of cell systems.
Right.
And that's something I can actually talk a lot about because I used to work in that industry before I got into HVAC. So
You definitely climbed to the top of your career.
I love more to come on that one.
Ty is on it. Ty is on it. So, you know, we're talking about refrigerants here. Now, not only did the names of the refrigerants change, the numbers of the refrigerants changed, and the properties of those refrigerants changed. So it was really easy when I had a paper PT chart in my pocket that I could pull out, but then new refrigerants started coming out. Right. And then I had to go find new PT charts versus now, all I do is I hit a button on my phone that says update on an app, and every new refrigerant that anybody wants to put out immediately is updated right there. I
So
can
it really
plug
comes
in.
down to efficiency is what we're talking about.
I mean, that's efficiency there.
Right.
That's efficiency. You know, and there's a lot of efficiencies that keep us going. What are you shaking at me there, Ty?
I'm sorry, there's a heck of a glare. All the different refrigerants, it's in this one simple little app.
It's magic, right?
And I don't have to
Magic.
use the magnifying glass anymore. I can see it. I can zoom in. It's great.
I will not go there.
Why do you think I'm wearing these things?
Right.
Oh yeah, what are those little numbers down there?
Yes.
So properties change. You know, a lot of these, your CFCs, your HFCs were single component refrigerants. And now we have blended refrigerants.
Mm-hmm.
When we started getting into the HFCs and the HFOs, we started seeing blends and we started seeing other things. And we started talking about things like glide, which means we have a different boiling point and a different condensing point at a single pressure. So that changes the world. That's evolution. Okay.
Mm-hmm.
I want to show an example here today. And we're going to use R422 series refrigerants. Now I put R422X because there's actually at least 4 different R422 refrigerants out there. And they still use the same components, but they use them in different percentages.
Sure.
I'm not worried about the percentages. That's up to the refrigerant manufacturers. They figure all that out.
Exactly.
They're the chemists. They have all the equipment to do the math and figure all this stuff out. That's the magic behind the scenes that we don't have to deal with and we're not qualified to do. All right. But R422 refrigerants are made up of R125, R134A, and R600A. Right. Now, it's got R600A in there, which happens to be isobutane, but they keep it at a low percentage, which means it is a non-flammable refrigerant. It's classified as A1, lower toxicity, non-flammable. Okay. So a lot of people saw that and panicked. Oh, it's flammable. It's got isobutane in it. What are we going to do? Oh, no, we can't. No, it's not flammable because it's a very low percentage. Right. But here's the thing. How many of us have heard stories about refrigerant mixing?
Oh man, absolutely. Like what?
Anybody heard of a hey, I got this R22 unit in here. I'm gonna go drop a little bit of a
R22 replacement.
R22 replacement. I'm just gonna juice it up a little bit. It's the same pressure, right?
Yeah.
Right. And Jason, thank you. I completely agree. Yes. Non-flammable, terrible term. No flame propagation, much better term. But people really have to think about what that no flame propagation is. If you're watching the comments. Thanks, Jason. So we look at that pressure chart and we think, hey, I'm going to match up the pressure. Right? I'm going to match up the pressure. But what do we do with that PT chart? What's the purpose of a PT chart?
Let's find my temperature pressure correlation.
Right. We want to find a temperature. We want to find a temperature so that we can either figure out what temperature a coil is going to be as a refrigerant changes state, or maybe we want to measure how far away from condensing or boiling that refrigerant is. Right. But if we mix things out in the field, what's going to happen?
Yeah, we're creating something new.
We have no idea. And I want to illustrate that with you for this. Remember, same three components, different percentages. Let's take a look at those four refrigerants at 230 psig.
Okay, so the same primary components, just different blended portions.
Same primary components, blended differently, right? A, B, C, and D. Okay. At 230 psig, A, 96.8, 98.9. B, 110 to 115. 98.2 to 100.8, 109, to 109.8, and 105.6. And I reversed those two on the bottom as I'm sitting here looking at it. This is what happens when you get trying to do too many things at once and you make a slide and you reverse two numbers. So hold on, back up, reverse that.
We can fix that.
That's easy to fix. I'll do that later. But my point is, if I said, okay, I got R422A, well, I don't have R422A on my truck, but that's what's in the system. Oh, wait a minute, I got some R422D in my truck. Let's put some R422D in there. It's close enough, right? It's the same components. Why just change that blend? Now I'm going to be somewhere between these points.
Something that's not going to reference at all.
Yeah. And this goes back to our gas laws that we teach in school a lot of times, is that those are based on ideal gases, and ideal gases are a theoretical gas. Anytime we start combining components, the pressures do add, but they're not like perfectly stacked on top of each other. They mix somewhat.
Okay.
So now we have these things in between here. The distance between these two is called glide. Okay, and this is where we talk about glide. But this is an evolution. This is a new thing we didn't ever have to deal with single component refrigerants.
Right.
And now we have something in between these two called midpoint. Well, okay, now we're starting to get a lot of stuff here. And we need this PT chart to do what? Measure superheat and subcooling?
Yeah, absolutely.
See how far into a gas we are, see how far into a liquid we are. Well, we're starting to get a lot of steps in here. And with single component refrigerant, it was pretty easy. We'd have a set of gauges. We might look at a PT chart based on the pressure we see on here. Okay. And we could make a really quick decision. But now we got to look at a pressure. We're going to measure a temperature. We got to figure out which one of these to use. If we want to know the average coil temperature, we have to calculate the midpoint in between,
Mhm.
which in a condenser, it's literally halfway between these 2 points. But in an evaporator, because it has a metering device at the beginning of it, it's a different calculation for your midpoint temperature. All right. I'm not going to go into the math.
No. 'Cause we're here talking about the evolution of
Right.
we're
talking
getting
about
there.
the evolution.
Hang in here with us, right? So we're,
You know
we're
what?
getting some of the math, but then we're going to understand why it becomes so much more critical using proper tools of today.
I have a math tool right here.
There we go.
I punch some things into this. Guess what? It gives me the midpoint.
Absolutely.
I use the right app. It gives me the midpoint. I don't have to deal with it. I don't have to remember all the mathematical formulas. I use tools to my advantage to be more efficient.
Yeah, absolutely. I just had this conversation yesterday when we were talking about doing calculations, and it was just exactly on this type of scenario. It's not about teaching that technology is the replacement of our fundamentals. It's showing that technology makes things a little bit faster, just like with my typewriter to my PC analogy. It's not that I'm teaching someone a new way to do things. I'm just showing them faster ways to do the things that we have been teaching them.
Right. And with a typewriter, I mean, you might be able to type at the same speed on a computer, but dissemination after you type it up, sharing it, saving it, editing it.
Yeah.
If you want to edit that, you either have to type over what you already typed, or if you really want to change something and completely reformat it, you got to type it all over again.
Yeah, exactly.
On a computer, right? It's what? Couple
Seconds.
button pushes, you push the right things, it reformats it, you throw a picture in there. Whew, that was fast.
That's right.
It's evolution of technology. And Ty, thank you. I love your bits on technology. Ty's the master of that.
Well, that's kind of what we segue Ty into here. So, as we talk about these transitions, all three of us have seen this evolution of tools and technology. And it really comes down to understanding the methodologies, understanding the fundamentals, and then putting into practice tools that makes us a little bit faster at our trade. Part of this is talking about the gap that we have in our industry. How do we start filling that gap? One very easy way for us to fill that gap is to be able to make ourselves more efficient. And so the tools and the technologies are there. Now it's a matter of getting comfortable using them, because a lot of us as educators may not have used the most modern tools. And that's really what we're here talking about is we want to be able to, discuss the fundamentals. We want to be able to show why things work, but then also be able to show how we can get to the outcomes a little bit faster using our modern technology.
Right, because employers don't want inefficient employees.
Exactly.
Employers want efficient employees. And if we're training people to go out there and do work, we need to train them how to do it efficiently. Now, sometimes some employers aren't that efficient, but that's their business model. They get to choose that. And one challenge is keeping up with technology is challenging. It's a full-time job sometimes to keep up with a wide breadth of technology. But
Exactly.
pick your lane and you can keep up with that. So, this kind of thing here, right? Technology makes this a lot easier, because if I went from, say, these two tools, this is an old Serviceman. I had to look and remember the name of it. Serviceman superheat gauge. Well, and an analog. Well, we replaced these with, we'll say, digital tools. Okay, I love my Cooper thermometers. They're fantastic gauges. I could monitor 3 temperatures at a time, but then I got to deal with this stuff everywhere.
Absolutely.
Right, and that takes more time to connect up and hook up and unhook and put away and take care of. And the evolution of that is now we go to completely wireless temperature sensors that we can clip onto a line or put into a duct and measure things.
So what about accuracy?
Well, accuracy is a big thing. Accuracy, going from something like this. So this gauge would be in the center half or the center third, depending on how the gauge is rated, it would be 2% of full scale on that gauge, versus the first and last third, or the first quarter and last quarter, again, depending on how it's rated. Those would typically be plus or minus 3% of full scale.
Okay.
So, or sometimes they do 3% of the plus or minus of the reading or full scale, depending on how the gauge is rated. And there's a lot of different ways that the manufacturers will rate them. Then when we start getting into, digital things, well, the evolution really was from manifolds. We went to things like this DigiCool, and this was really one of the first robust, reliable digital gauges out there. Oh, look at Ty down there. What is that? What is that, Ty?
It's a Charge Master.
Oh, wow. I don't even know as I've ever seen one of those.
Yeah.
Cool.
I'm glad you brought that up. I haven't seen one of them in forever.
Man, that's neat.
Mm-hmm. So we're back to using, mechanical pressure readings. We're using mechanical temperature readings.
Yeah. So, the first evolution of these didn't even have a temperature sensor on it. It was just literally a pressure and a digital PT chart built in here, so that it would tell you your dew point, your bubble point on the refrigerant. It would take the pressure and immediately tell you that out of it. Right? So that was an evolutionary. And then the next generation came out with a single temperature probe on it, and you would switch it back and forth between the lines depending on what you wanted to charge with. And then the marketplace said, hey, guess what? We want 2 temperature probes so we can look at superheat and subcooling
at the same time.
Simultaneously.
Wait a minute.
And we don't have to wait for that temperature probe to stabilize if we need to switch between 2 lines. So then we had 2 temperature probes coming out of it. And then it evolved because the early generations of this would only show you superheat or subcooling,
not simultaneously.
Not both simultaneously. So it evolved again to be able to show both simultaneously. And all of this has happened in my time in the career, and it's evolved so fast that this company's out of business now.
Wow.
Because they couldn't keep up with the marketplace. They were a small company and they couldn't keep up with the marketplace. But that was an evolution. That was things happening. It was people asking for stuff. So that's why there was so many changes to that tool. And now we're into smart probes. This loses less refrigerant. I don't have a bunch of refrigerant sitting in my hoses that I have to deal with.
Yeah.
I don't have to deal with wires or a lot of hoses with these things.
Sure. I see Ty's brain going over there.
Ty's got all kinds of stuff there. Yeah. Yeah, all kinds of probes there. And we've had short, stubby analog gauges for quite some time. A lot of people would only use them on critically charged systems. There you go. Ty's got all the tools. Apparently, I thought I had a lot of tools here. Ty's got me beat.
So we start with mechanical pressure. We start with mechanical temperature.
Yeah.
Form a calculation for superheat. We move to a mechanical pressure, did a mechanical temperature, form our subcooling. As we're progressing, we're adding one, we're adding to another, we're getting tighter on our tolerances, and now we're leading into, now let's get into some of our more critical temperature pressure readings.
So now we start matching up a phone and probes, or it can be a manifold with Bluetooth, but the probes are nice because they are in a lot of ways faster. They're lighter, they're easier to carry around, they're smaller. You can put a lot more than just 2 on to monitor pressure if you want to monitor pressures in multiple spots. So I think there's a lot of advantages to them, and I love them. But that's where we have evolved in over time. But the cool thing about that is that when I evolved to these, now it does all the math for me.
Okay.
Right? In my device is doing all the math. It's not the probes. The probes are just transmitting something.
Sure.
Right? They're just transmitting a signal saying, hey, this is what I have. So I can select any refrigerant I want now. This is not necessarily refrigerant specific. as long as it's within the certain safety classifications of refrigerants, and in the right environment. But this has been an evolution. I was lucky enough to be actually watching and had a small amount of input even into the early days of the iManifold and what's now turned into MeasureQuick over time.
Yeah, absolutely. I've got my iManifold over here. I
Um,
actually won it my first year at the conference, by the way.
Nice. Yeah, I still got one sitting out there myself.
Sure.
But I was actually, like I said, lucky enough to watch that forum where all that idea kind of generated from, and get to see the input that went into that. And that came from a group of technicians wanting more information and wanting to automate that information, because guess what? They were tired of doing math and not knowing all this stuff. Because you realize that when you look at a refrigerant system or a system in general, it's a system, it's dynamic, it's constantly changing and fluctuating a little bit.
Absolutely.
They wanted to be able to see all that information gathered in one central location, rather than having to look at 5 or 6 or 7 different gauges and things like that.
Well,
Which
and
was
and also by the time that I started out using checklists, and we had very extensive checklist, but by the time you got the information from the equipment, from your instruments, converted it and put it into the right spots, and then did the math, by the time you get this number and then you did stuff and then you got this number, the system changed. And so by the time you got all of your readings, there was a time change between you get your numbers. So there was a huge accuracy loss, not only in time it takes to write everything out, and you can just write in numbers, but the time change even if you did it right. So now when we have things like MeasureQuick, I mean, it's amazing because I can just hook up my pros, get changes. I can make it instantly see, and I think that's absolutely. I don't have trouble with numbers and letters, really. And when it's to MeasureQuick, the data comes in from digital gauges or into any app, and it calculates everything for me. It does that math for me. I don't have to worry about getting my numbers mixed up. And then I can print that, send it to a customer, save it for later, data log. To me, it's been tremendous. And I fought technology for a while. I mean, as you can see, and but I've fully embraced it, and now I look back and think, this is really amazing.
Yeah.
there should be a song written about that called "I Fought Technology and Technology Won."
Oh my gosh. All right. Hold on. All right.
Make Howard a note about that.
Yeah, exactly. Right, so it comes back down to, we continue to evolve with our tools, which are really making the job site analysis a lot faster. And now that we're getting into blends, this is where we're segueing into why is it going to be so important understanding tools and technologies and reading accurately going into new generations of refrigerants and new generations of equipment, because it comes down to being very much about the performance and being specific with our calculations. Saving time is going to be of the essence going forward.
Yeah, it is. It's saving time because that helps where it allows us to do more with less workforce, which we obviously have workforce limitations right now. And it allows us to do it more accurately. The equipment is demanding it. Right? If you look at the manufacturer specifications on equipment and what they're desiring us to dial that in to get the equipment performance that is even the equipment's rated at, we have to have better instrumentation. We have to have the ability to take that information in, and it's honestly a lot more that we can process in the human brain in a very, very short period of time. So we need to get that information because we need to take the output of that information. Our job really as the human is to interface between the information that our instruments give us and our customers.
Mm.
We are the interface between that. We need to get that raw data in a way that we can understand it, and then we flip that data into a way that our customer can understand it and make an educated decision.
Absolutely. I did a podcast, actually just released, I don't know, I'll be releasing it tomorrow, actually, So, segue. So, I have a podcast releasing tomorrow where we talk about the importance of proper measurements when it comes to doing system analysis. If we talk about the evolution of tools and we talk about evolutions of industries, when was the last time that you went to a doctor and he pulled out the thermometer, a glass thermometer, to check temperature, right? It kind of comes back to the same technologies as we are looking at, right? We are now moving into being able to gather that input faster so we can do the calculations faster so that we can have a output that is faster than we've been able to do in the past.
Well, and we're also able to gather more information than we ever have before.
Look at that. Prime example. Good call,
you know,
Ty.
We got is that a
Psychrometer.
that is a sling psychrometer, isn't it?
Right. So if
It
we talk
is.
about measuring, temperature and humidity and getting wet bulb and dry bulb in the past, it would take time to be able to get that calculation, not including the time that it took to actually wet the wick to get a proper measurement. Where now we can do that in seconds with digital tooling.
Ty, how big of a hole do you have to put in a ductwork to stick your arm in and sling that thing around inside of a duct?
Oh, I use the evolution to the newer one.
There you go.
Oh, okay, good. You got the newer version there. Nice, nice. I'm glad to see that. Nunchucks. All right, now I want to see Eugene at the conference walking around twirling twin sling psychrometers.
Don't say that. I'll do it. I'll get them ordered. I still got days left.
Dangerous. So this is another evolution here, right? How many people in the chat know what that is? And my boss Bill's in the chat. He's not allowed to answer because I know he knows what that is.
I am stuck. I see is that a mechanical pitot tube? Well, wait.
Really,
Hop
no.
in here, Ty. All right. You got me stumped.
So that is a Fyrite bottle.
Oh. Okay.
That is a combustion analyzer.
Yeah.
That's a very, very early combustion analyzer. So you would fill this up with a chemical in here. You'd use the sample bulb to pump the sample in here, and that would tell you how much CO2 is in the flue gas stream.
Wow. Now we're talking
Just
about
one-time sample.
All right.
It was a very early version of that. How many people use that still? None.
Wow.
No, we don't. We have these now. They're called combustion analyzers. They're electronic. They feed us information into our electronic systems, allow us to get more accurate data, output quicker, and change things up. I mean, we used to think that flame color was the end all be all of the way to set up and check burners, and we now have electronic instruments that show us otherwise. So what is Ty got down there? Holy cow!
So
Ty's got his. Is that a new Fyrite?
Correct.
well, okay, so yeah, new for me, but I remember I was the top tech because I had the printer that went with it. So talk about evolution. Like,
can you hook the printer up to this?
I couldn't do that one. Well, I did. I had to
run some paper out and write it down. Oh, here goes Clifton again with his typewriter.
I almost, Mr. Customer, we have 0.0222.
I want to see the tool bag you carry that typewriter in around into a job site to type up the report for the customer. And we see other evolutions, right? How many of us still walk around using this thing?
Not very many.
Not really. I know Ty's got one down there.
It's here somewhere. I couldn't find it precisely.
Ty probably uses it occasionally.
The batteries take a long time for they wear out.
Yeah, a little bit of charge time there.
And that led us into the modified ORSAT device. Bill will have to tell me about that one sometime.
I have to find that one.
So, from manual tools, right? We moved into power tools.
Arr, arr, arr.
More power, more power. So this one's kind of cool because it's all metal, so it's really, really durable, right? And there's a little thing. It's got a 3-prong cord on it.
Takes a little time to set up in the field, doesn't it?
Well, I mean, it takes extra time, but why did we move away from metal bodies on power tools? Right? Because if the motor went bad in there and it electrified the case, that's why we have to have a grounded case on it. We got to have a 3rd prong on there to be able to ground that case to keep from shocking ourselves.
Yeah, the reason was shocking.
Yeah, it was shocking. It was a shocking transition. And then, we went to things like this with polycarbonate bodies. Yeah, right, Jason. That's the prong you cut off because the outlets didn't have the 3rd prong on them. So what? We don't need that, right? Who needs that?
That's exactly right.
What the heck, right? We moved into plastic bodies. Well, that's an insulated body, so it's a fiberglass or a composite body. Now it doesn't have a 3rd prong. It doesn't need to have a grounded case on it. So it's only 2 prongs. So if we cut one of those prongs off, it's not going to work well. But it'll plug into more outlets.
Yeah, absolutely can.
And then we went into things like this, right? Now we got cordless drills. I mean, we got cordless hammered. We got cordless everything these days. I mean, even in cordless drills, we've seen an evolution, right? Because who goes out and searches for a NiCad battery? Who goes buys a drill with a NiCad battery today? Heck no, I'm not buying a NiCad battery. I'm going to go buy something that says lithium ion on it because they last longer. They hold up better.
Absolutely.
There's all kinds of evolution happening around us all the time. Do we use this anymore? What's that? Anybody know what that is?
Probe.
Anybody seen that? Here?
Absolutely.
I'll give you a better close up of it here. There's a little better close up of it there, right? That's an early amp clamp. That's an analog amp clamp right there.
Absolutely. I think Ty's, man.
Ty's
got that.
That Ty's got one there too. Yeah, different kind. We don't use this anymore. That's an early Simpson 260. Yeah, some people still own them, but I don't see them carrying around in their trucks and their tool bags. No. Now we have this. It's got clamp in it, does all that stuff. It does way more than those 2 original instruments put together in a much smaller and lighter weight package. So tools have been evolving for a long time. I suspect they're going to continue to evolve. Just as the rest of the trade is.
So when we start seeing an evolution of tools and we know that we're moving into faster, lighter products, what do you see as the primary products going into 2024 that we should be focusing on to look at for the classrooms?
Well, I think we should be focusing on anything that is really starting to become more mainstream. Probes are a big one.
Mm-hmm.
I see a lot of people that are really afraid of refrigerant probes.
Sure.
And they are different to charge with. And that's one of the biggest complaints of people I hear is, how do you charge with that?
Mm-hmm.
Okay. You screw it into a T. Okay. There's a little T that screws in here. And then you run a hose over to your refrigerant tank with a ball valve in it. That's it. That's how you charge with it. And you can actually, some of the some brands of probes actually have a charging port on them where you can screw a charging hose directly onto that port, already built into it. There's a lot of different brands. Oh man, Ty's got the camera out there too. Holy cow! Look at that. Airflow testing is another one that's become a lot easier with the evolution of tools, especially in the residential, the smaller system sector. We now have the, yeah, absolutely, Jason. That's a great comment. The students coming into class today have never not known technology.
Absolutely.
Right? Remember, we talked about the smartphone's been around for close to 20 years now. As far as the touchscreen smartphone that we're used to today. And so there's a whole generation there that's coming into school that has never not known a world without, they've never known a world without a smartphone. It's always been around them.
Sure.
So I hear a lot of teachers say, I don't want my students using phones in class. I say, teach them how to use those phones. Figure out how to use it. Figure out how to get them interested in using it. Places like Measure Quick or some of the other apps you can use, have them start generating reports off of those smart tools when they're doing work in the class. Make them generate that report with their smartphone. Make them hand that in. Make the completion of that report part of their grade.
Yeah,
Heck,
Absolutely.
that's something that's pretty easy to do. Especially if you got tablets in there or anything like that, smartphones. Things are just getting to where we can do that really easily. Oh man!
All right, Ty, we
that,
need some
Ty?
explanations.
No kidding.
Well, Eric had mentioned airflow, and this was the Alnor anemometer, so you could measure airspeed. Then you could calculate, if you knew your airspeed, you knew the size of the hole, you could calculate your CFM coming through it.
Wow, where did you find that?
Well, I worked with a lot of old school people, and this is one of the reasons I embraced technology, because I thought, this stuff was cool, but it took forever and it wasn't practical. And now with apps, I can simply take pressure readings, and using apps like Measure Quick, I can calculate this stuff so much faster. Or my favorite, which I don't personally own one yet, but is the True Grid. You slide it in and you use technology and you get the instrumentation numbers right away. So what I like to do, because students get overwhelmed with some of the stuff that we're talking about, so I like to show some of the antique stuff, and then they roll their eyes because that's boring, it's horrible. Like, hey, you guys want to read airflow with this? We can do a bunch of math or calculations, and they're like, oh, you lost it, right? I say, hey, what if we use technology? And then you show them the True Flow Grid, or you show them the flow hood, and you can they hook it up to it and press buttons and numbers come up. That then they're connecting to it. Now they have an appreciation to it. So not just that it makes our job faster, but it gets the new generation going, wow, that's cool. I can do that. I can see myself doing that. And so, everybody wins.
Yeah.
So one of the questions that just came up, Ty, you're just bringing up the point about apps. One question that did come through just a minute ago was, what app are we using for the PT charts? And I think particularly the one that you were using, Ty. And if you'll give me that, I'll actually pull it up and talk about it. So let's talk about some of the new technologies while we have a little bit of time left, as ways that we can introduce new technologies, new apps, utilizing the smartphones in the classroom, along with some of the new digital tools that we're actually introducing.
So I'll throw my favorite one up there too, which is the Bitzer PT chart app. I've been using it for quite some time, and I think it's probably one of the most flexible ones and has the most refrigerants in it that I've found.
And Ty, what about you? What's your favorite go-to?
For just PT, gosh, I really can't choose a favorite because I rotate between them so that I don't get stuck on just one type, or if they change it, I don't get mad that, oh, they changed it. I hate change. So I rotate through them, but there are so many great apps, for example, like the Copeland mobile app, where you can find out what the amperage is supposed to be on a compressor. You can scan the compressor and find all the information about it. Even if you ohm it out, hey, what's a good ohm? I don't know. You can literally use your phone and find that information. Like the HVAC school app, it has some great on-demand learning. You're kind of freaked out. You don't know what to do. Don't know how to solve that problem right then. They have that. And there's actually calculations about the recovery tank. I remember we did recovery tank calculations in class, and you do math, you lose the students. But we do that school app. It has calculations for the recovery tank. It has you pick what refrigerant, you ask what you're looking for, and it does the calculations for you. You just put the numbers in. I mean, there are some amazing apps, and I hear a lot of instructors, and I was one of them once upon a time. Hey, they don't want them using the phone. I say, put your phones out there. Let them put the phones on there. And if you see 2 or 3 people start going to the phones, then you need to change. You as the instructor, you're the leader. Change. Let's modify. I'm losing them. It doesn't matter if they're looking at their phone or they're staring at you spaced out. You're already losing them. So when everybody starts going to the phone, cool. Grab your phone. We're going out to the lab. We're going to do something. Or I've even had it where we walked around the building and people had their phones and we took turns going over, book stuff, but we were literally walking around the building, or we'll climb up onto the roof and we'll do class, on the roof, whatever it takes to get people moving. But this is your most important tool. Well, actually, this is your most important tool. And then with this, you know how to use this.
So here's something too. You mentioned not doing math, right? I don't like doing math. But you know what? This thing does have a calculator on it, right? But I still have to remember what the formulas or anything else to put into that math. You still have to punch it all into a calculator. But these also have a really neat thing in them called a spreadsheet. Now, a lot of people get really scared when they hear spreadsheets because you can get really involved. But a cool exercise for your students is something that I did for myself is I use a spreadsheet program that comes with the phone. Apple has one, Google has one. You can use the Google on the Apple, whatever you want to use. Start building spreadsheets with formulas in them. So all you have to do is pull it up on your phone. If you do it in a format where you can scroll up and down through it, you build that formula into the spreadsheet. You can have your students build their own spreadsheets because that's a useful tool for them later on. Have them build their own build those formulas out of the books into the spreadsheet and say, here, now you have your own calculator. If there's not an app out there that will do it for you. And it's a really simple thing to do. And it made my life easier because then I don't have to remember all the mathematical formulas for different things, because some of this stuff, okay, if you get into higher math, it's not super complicated, but I think I have better things to fit into my brain and use my brain for on a daily basis. Like I want to build that in there. I want that to do the calculations for me.
Sure. It comes down using the smart device as a smart tool. And it's really what we're talking about.
I'll tell you some of the best things I found that really helped not only students, but also technicians and me myself, was being able to organize that information, knowing how to set up folders. If you take pictures, whether it's pictures of jobs or pictures of information you want to get later, put that into a formula, hey, airflow calculations. And even if you just took a picture of a formula, put it specifically in that folder so that when you needed it, you knew where to find it. Because there's an overload of information. So you got to know how to find that information when you need it.
Yeah, it's all about being more efficient at the jobs that we're doing, whether it's in the field, whether it's in the classroom. It's about using modern tools, modern technology to become as efficient as we possibly can. 100%. All right. Well, what do you think, guys? What's our leaving analogies here? Do we have any things we want to top off? Do we have any further questions we want to dive deeper into? I know we're going to be at the AHR we'll be there Sunday. We'll be there Monday through Wednesday, doing podcast on Monday and Wednesday. Tuesday, we're going to be doing a lot of doing interviews with people. How about you, Eric? Where are you going to be?
I'm going to be all over the place.
Right.
I've got a lot of meetings. Of course, we work with a lot of the vendors there. We meet a lot of our vendors there, and I want to walk the floor and see some of the new things that come out. To me, that shows a lot of fun, and I really enjoy walking the floor and just seeing products as they come out, because that's where a lot of new products are launched and things like that. So, and that is a place where I can go and look. Yeah, everybody else can go and look too, but there's a lot of people that aren't going to be able to make it there. So,
yeah,
hopefully we like to watch and make sure that we have the newest products on hand. And if we see something innovative there, we look for it.
So let's talk about that real quick before we hop out of here. Let's talk about TruTech and ways that people can learn more about TruTech tools and what you guys do for the industry.
Well, I mean, our website, TruTechTools.com, that's our storefront. We got a lot of information on there. It's ever evolving. We're working on updating a lot of our information that's maybe a little bit older, and bringing it a little up to date with things that have happened and things that have changed in the industry. You find us on social media: Facebook, LinkedIn, Instagram, all that kind of good stuff. YouTube, lots of good things there. And I'll be at AHR. I'll be at the symposium down in Florida. I'll be at the educators conference. I'm sure I'm going to see a lot of people there that are watching. And we also do a podcast. Bill and I do, called the Building HVAC Science Podcast.
Yes.
where we dig into a lot of other stuff as well. So
All right. Well, it
a lot of
sounds
a lot of things going on.
yeah, absolutely. A lot of things happening in the industry right now, and we look forward to seeing you at the AHR. We'll see you down at the symposium. Daniel and Jason and Ty will all be down there, and I will. I think Jason said down there. I know. No, Jason, Eugene, Ty, and Daniel will be down for that one. Then we'll see you all at the National HVACR Education Conference. Ty, any final parting words?
I tell you, if you guys get the chance to meet Eric and Bill, they are great people, full of knowledge. They're not going to try to force you or sell you anything. They just love this trade. They're people of the trade, for the trade. If you get the chance to get to know them, I mean, they're just a wealth of knowledge, and they're always willing to help somebody. So don't miss that opportunity if you get it.
Absolutely. Eric, last parting signs?
I'm looking forward to seeing everybody, and thanks for coming out today, and thanks for having me on, Clifton and Ty. It's been a blast, and I always enjoy hanging out with people smarter than me. So here I am.
Hey, welcome to the evolution of an industry. And that's really what we're leaning to is the evolution of an industry, an evolution of tools, bringing new technologies into the classroom, new tools into the classroom. And anyone looking for further information, get a hold of Eric and get a hold of True Tech Tools. And we will see you all next week on Did You Know, the ESCO HVAC show. Thumbs up, Ty.